Hi everyone, welcome to today's video on slope. So slope is the steepness of a straight line. So what do I mean by that? If we graph a straight line like these three over here, so looking left to right, it kind of looks like we have a person walking up a hill. And the person walking up this hill is going to have a harder time than the person over here walking up this hill. And that is because this line has a larger slope. So the larger the slope, the more steep the straight line is. So by more steep, I mean the closer it becomes to becoming vertical. So this one is closer to becoming vertical than this one. So this one would have a larger slope. Now when you have a negative slope, if you're looking from left to right, instead of going up the hill, this person is now going down a hill. So when they're going down, it's a negative slope. And when you're going up, it's a positive slope. And the more negative the slope, so if you go from like -1 to -8, it's going to become steeper and steeper, but still in the negative direction, so still going down. Now, how can we determine slope? So one of the methods of determining slope is by using this thing called rise over run. So the first step would be to find 2 points on the straight line. Now this can be any 2 points on the straight line. And your second step is to calculate the slope using this equation. Slope is equal to rise over run. So your rise is going to be the vertical distance between 2 points. So let's say we have our point here and our point here. The vertical distance between those 2 points would be 3 because we're going from 0 to 3. And we're going to divide that by our run. So our run is the horizontal distance between 2 points. So if we still are looking at our 2 points here and here, our horizontal distance between them would be 2 because we're going from 0 to 2. So to calculate our slope, we have our rise over our run. So our 3 divided by our 2, giving us a slope of 3 over 2. We can do the same thing over here. So if we're looking at 2 points, like one here at the origin and one over here at 3, 1, our rise would be our vertical distance between these 2 points. So it would be 1 because we're going from 0 to 1. And our run would be our horizontal distance between the 2 points. So that would be 3 because we're going from 0 to 3. So our slope would be our rise divided by our run. So 1 divided by 3 for a slope of 1 over 3. And as you can see, the larger slope, so the 3 over 2, is more steep. So if we had a person over here, they'd have a harder time going up this hill than a person would going up this hill because this is a smaller slope. And slopes can also be negative if either the rise or the run is negative. And that is because if we have slope is equal to rise over run, if the rise is negative, then our slope becomes negative because negative divided by positive equals negative. And if our run is negative, then our slope also becomes negative because positive divided by negative is also negative. But if our rise and run are the same value, so they're both positive or they're both negative, then our slope would be positive because negative divided by negative is positive and positive divided by positive is also positive. So in this case, our slope is negative because if we're reading from left to right, we can see that our hill is going down and our slope is -1 because we're doing rise divided by run. So our run is going 1 to the right and our rise is actually going 1 down. So if we follow this over here, where up and right are positive. So if we're going up, our rise is positive. If we're going right, our run is positive. But if we're going down or left, then it's negative. So if we're going down, our rise is negative. And if we're going left, our run is negative. So if we look at our 2 points over here, our run is positive because we're going 1 to the right and right is positive. But our rise is negative because we're going 1 down and down is negative. So if we do our rise over run, we get -1 divided by +1, which gives us a slope of -1. Another method of determining slope is using coordinates. So every point on a line has an x coordinate and a y coordinate. So for example, if we look at these 2 points over here on the graph, point 1 has an x value of -1 and a y value of -2. And point 2 has an x value of 3 and a y value of 2. But generally for points 1 and 2, when we're referring to two random points on a straight line, we refer to point 1 as just x1, y1, where the 1's represent point 1. And for point 2, we refer to it as x2, y2, where the 2's just refer to point 2. In this example, I made this point 1 and this one point 2, but really it doesn't matter. This could be point 1 and this could be point 2, or you could choose different points entirely. Now your rise is the vertical distance between the 2 points, so that would be this distance over here. And you get that by doing your y2 minus your y1. So remember, your y2 is the y value of point 2, and your y1 is the y value of point 1. And your run is the horizontal distance between the 2 points. So that would be this distance over here. And you can calculate that by doing x2 minus x1. Now remember, slope is equal to rise over run. So if rise is equal to y2 minus y1 and run is equal to x2 minus x1, then we can plug that into our equation for slope, and we get this new equation for slope, where slope is equal to y2 minus y1 divided by x2 minus x1. So let's use our new equation for slope to calculate the slope for this example. So first, let's find our coordinates for point 1. So point 1 has an x value of -1 and a y value of -2. So let's write that down. Point 2 has an x value of 3 and a y value of 2. So let's write that down as well. Now let's plug these values into our new slope equation. And slope is often referred to as m, because in the equation y equals mx plus b, m is our slope. So plugging that in, y2 is equal to 2 minus y1, which is -2, and x2 is equal to 3 minus x1, which is -1. So that gives us 2 minus -2, which is the same thing as 2 plus 2, which is 4, divided by 3 minus -1. And 3 minus -1 is the same thing as 3 plus 1, which is 4. And now 4 divided by 4 is equal to 1. So our slope is equal to 1. And we can check this because what this means is that as we go 1 to the right, we go 1 up. So if we go from point 1, we can see if we go 1 to the right and 1 up, we arrive at another point. And then 1 to the right and 1 up, we arrive at another point, and so on until we eventually reach point 2. Now let's go over some examples. Stacy looked at this line segment and concluded that the slope had to be negative because the coordinates of the points contain negative numbers. Is her reasoning correct? Explain. So first, let's think about what makes a slope negative. Remember, we said a slope is negative if when we look from left to right, the hill is going down. So in this case, if we had a person on this hill, they would be going down the hill. So this would be a negative slope. But that's not because there are negative numbers in here. We can look at another example of a positive slope that also has negative numbers. If we look at this line, for example, you're going to have some points that are in the negative quadrants. Remember, you would have like -1, -1 here, -4, -4 here, for example. So these values would be negative. But this slope is still positive because if we look from left to right, the person on this hill would be going up. Another way to differentiate a negative slope versus a positive slope is that a negative slope has either a negative rise or a negative run, not both. Whereas a positive slope has both a negative rise and a negative run, or a positive rise and a positive run. So if we look at our example over here, as we go to the right for our run, so our run would be positive, we're going down for our rise, so our rise would be negative. So a negative rise and a positive run results in a negative slope. Now let's look at example 2. A line segment has one endpoint of A, 2, 3. Part A says to plot the point A on a grid. So if A is 2, 3, that means the x value is 2 and the y value is 3. So if we were to plot that, we would go to x is 2 which is over here, and we go up 3 spaces. So we go up to y equals 3. So our point would be right here. Part B says to use the slope 1 over 2 to locate another possible endpoint B. What are the coordinates of point B? So if the slope is 1 over 2, so m is equal to 1 over 2, and we know that slope is also equal to rise over run, then we know that our rise is 1 and our run is 2. And since these are both positive, we know we're going up and right. So we're rising by 1, which would bring us to 4, and we're running by 2. So that would bring us to 4 as well. So point B would be at 4, 4. So the coordinates of B are 4, 4. Example 3 says, given a point A, 1, negative 4, find the coordinates of a point B so that the line segment AB has each slope. So basically we know one point and we know the slope, but we need to figure out another point. So our equation for slope is m is equal to y2 minus y1 divided by x2 minus x1. So let's just let A be our first point, so x1, y1. And B will be our second point, so x2, y2. So for part A, our slope is 1 over 5. So m is equal to 1 over 5. And that is equal to y2 minus y1 divided by x2 minus x1. But we already know our x1 and y1, so we can plug those in. So from this, we get 1 over 5 is equal to y2 plus 4 divided by x2 minus 1. So one way we can get these fractions to equal each other is if the numerator equals 1 and the denominator equals 5, then we'd also end up with 1 over 5. So from that, we get two equations. Equation 1 is going to be 1 is equal to y2 plus 4, and equation 2 is going to be 5 is equal to x2 minus 1. Now we just need to solve for y2 and x2. So to get y2 by itself, we need to subtract 4 from both sides. When we do that, we get y2 is equal to negative 3. And to get x2 by itself, we need to add 1 to both sides. So in doing that, we get x2 is equal to 6. And remember, point B is equal to x2, y2. So we end up with B is equal to 6, negative 3. And since the same point is used in the line segment AB with these various slopes over here, we can reuse the same equation but just changing the slope each time. So let's do question B. So for question B, our slope is negative 1 over 5, and that's going to be equal to y2 minus y1, which is negative 4, so y2 plus 4, divided by x2 minus x1, which is 1, so x2 minus 1. So because of the laws of division, if this negative sign is either on the 1 or the 5, then this whole fraction becomes negative. So I'm just going to put it on the 1. So from that, we get our two equations, where our first one is negative 1 equals y2 plus 4, and our second one is 5 is equal to x2 minus 1. To get y2 by itself, we need to subtract 4 from both sides. That gives us y2 is equal to negative 1 minus 4, so negative 5. And for our second equation, to get x2 by itself, we need to add 1 to both sides. So that gives us x2 is equal to 5 plus 1, or x2 is equal to 6. And since b is equal to x2, y2, we get our point B is equal to 6, negative 5. And if we were to plug in our x2 and our y2 and our x1 and our y1 into the slope equation over here, we should get negative 1 over 5. And now I'm just going to do the same thing for part C, D, and E. And that is going to be equal to y2 minus y1 over x2 minus x1. But I'm just going to use the same part as before since our A coordinate is the same. In order to get our two equations, we need to make sure we have a fraction on both sides of the equal sign. 2 is the same thing as 2 divided by 1, so I'm just going to rewrite it that way. So now we get our two equations, with our first one being 2 is equal to y2 plus 4, and our second one is 1 is equal to x2 minus 1. Solving, we get y2 equals negative 2 and x2 equals 2. And since point B is x2 comma y2, we get point B is 2 comma negative 2. For part D, our slope is 0, and when our slope is 0, that means we just have a horizontal line for our graph. 0 is the same thing as 0 divided by 1, as anything divided by 1 is itself, and that is going to be equal to the same portion we had from before. So y2 minus y1 over x2 minus x1. And all I've done over here is just plugged in my x1 and y1 values from point A. And from this, we get our two equations, where our first one is 0 equals y2 plus 4, and our second is 1 is equal to x2 minus 1. So solving, we get y2 is equal to negative 4, and x2 is equal to 2. And our point B would be x2 comma y2, so 2 comma negative 4. Lastly, for E, our slope is undefined, and that happens when our graph is a vertical line. So if we were to pick 2 points on the line, we would have a rise, but we wouldn't have any run, so our run would be 0. So for our slope, our run just has to be 0, but our rise can be any number. So I'm just going to do 1 in this case, but our run needs to be 0 for an undefined slope. And the reason we call it undefined is because you can't divide a number by 0 in math. And if you were to punch into your calculator any number divided by 0, you would get an error message. And that's why we call it undefined. Anyways, this is equal to the same portion from before, so y2 minus y1 over x2 minus x1. And from this, we get two equations. So equation 1 is going to be 1 is equal to y2 plus 4, and equation 2 is going to be 0 is equal to x2 minus 1. So from this, we get y2 is equal to negative 3, and we get x2 is equal to 1. So point B, which is x2 comma y2, would be 1 comma negative 3. And remember, when I say point B, this is just one of several potential point Bs on the line segment. Because if you can imagine your grid like this, and your straight line here in red, let's say this is point A, we have infinite point Bs to choose from. So just because I gave this one example here, and this one here, and this one here, that doesn't mean there aren't several other potential Bs you could have also written down. Anyways, that's it for today's video. If you liked it, please leave a thumbs up. Let me know what you want to see next in the comments down below, and I will see you shortly in the next video.